So this is my lab report on the charge tapes lab. A quick overview of this video report. I'll introduce the experiment from this lab and relative physics principles, show my calculations and code for the experiment, and then conclude with the reflection on the experiment and some further extension questions. So the goal of this experiment was to determine the amount of excess or deficient charge on a piece of Scotch tape. The idea was to determine the sign of the charge based on the tape's interaction with an object of known charge. So I used a negatively charged pen to deduce that the tape had a positive charge since they attracted each other. Then we can use a free body diagram to balance gravitational force in the negative y direction with electrostatic force from a similarly charged piece of tape in the positive y direction to calculate the amount of excess or deficient charge on the tape. In this case, deficient charge, which came out to be 1.4467 times 10 to the negative 9 coulombs. And then knowing the number of atoms on the tape on the sticky side, using its area, we can determine the ratio of atoms to electrons seen here. So some important underlying physics principles in this lab are the idea of likes repelling and opposites attracting in terms of positive and negative net charge, which is how we deduce the sign of the charge of the tape. Additionally, Coulomb's law, written here and pictured here, gives us the electrostatic force of attraction between 2-point charges or spheres with evenly distributed charges. Obviously, the charges on the tape are distributed across its area, but we simplify this real-world situation on the right with this free body diagram to approximate the charge on the tape. So we do have to consider the simplification when we evaluate our results. So the diagram shown on the right models the forces in the y direction which act on tape B. The forces in the x and z direction cancel out. The force of gravity from the Earth exerts a force in the negative y direction, and the electrostatic force from charges tape A exerts a force in the positive y direction, which sums to 0 since tape B is not accelerating. So then using Newton's second law, we know that F net equals the force of electrostatic attraction plus the force of gravity. And since it sums to 0, we know that the electrostatic force of attraction is opposite in magnitude to the force of gravity. So these are the calculations based on this diagram, which you can pause to see. We use this to determine the mass of tape. We also consider that both tapes have the same charge, so Q1 equals Q2 in Coulomb's law. And then the charge comes out to be roughly 1.4467 10 to the negative 9 coulombs. We can also calculate the ratio of atoms to electrons on the sticky side of tape B, shown on the screen. I performed these calculations in glow script, and the code is pictured here. I represented the tapes as point charges or spheres in the window, as they would be in the Coulomb's law simplification. So as you can see here, the vectors in the y direction cancel out on tape B. This is tape A. The values are reported here. Some important simplifications and assumptions for this lab besides the Coulomb's law simplification, which I've already explained. We assume that each tape had equal amounts of charge, so that in the equation for Coulomb's law, Q1 equals Q2. We also ignore forces besides the electrostatic force and the gravitational force acting on tape B in the y direction, which allows us to set the forces equal to each other. So we assume the effects of something like air resistance are negligent. Extending this experiment further, we can consider these two questions. If the signs of the charges of protons and electrons flip, the tapes would still repel, so the forces on tape B in the y direction would still balance out. However, tape B would have a negative charge and excess electrons instead. Additionally, an important consideration in this lab is that the charge transfer between the tapes and other objects is minimized. If charges started transferring between the tape and, say, a neutral object, excess negative charge would spread out. The tape loses its original value. And then here is the link to my glow script code if you'd like to see it. Thanks.